Let's take a little time to reveal the prehistoric stories that the earth once concealed. Mix them all together on this ancient land. It's time to spread some Palaeo Jam. Hello, welcome to Palaeo Jam. I am your host, Michael Mills, and around about 12 months ago, we did an interview. It was our first Zoom interview, and I've done lots of podcasts via Zoom since then. So our next guest is a trailblazer, not just for that, though, but for so many other reasons. And we're going to talk about some of that. I am speaking with Eleanor Beidatsch. G'day, Eleanor. Welcome back to Palaeo Jam.
Well, I'm very happy to be here.
And great to see you, because I get to see you, the listeners don't. But
Yeah.
so 12 months ago, the podcast, the title was A Journey into Accessibility, Digging for Fossils from a Wheelchair, and we talked about a bunch of things, including the research you were doing at the time. And so since then, you've graduated with first-class honours.
I have indeed.
I should probably insert applause now or something like that, but I mean, firstly, well done on that. For those who haven't listened to that episode, and there'll be a link in the notes, but can you just tell us a little bit about what the research was that formed that honours?
Yeah, sure. So for my honours, which I did over 2 years because I went part-time, I was researching Cambrian lobopodians. So the Cambrian era, of course, is about 520-ish million years ago. And it is, well, that's the early part of it. And it, of course, is very exciting to be paleontologists because it marks the beginning of complex animal life. So it's when you start to get the first proper invertebrates living in the ocean. And also, the era when you get this event called the Cambrian explosion, which sounds a lot more metal than it actually was, but basically it's when this massive bioradiation event occurs, and it's the start of the stem lineages of pretty much every animal group still alive today. And it's represented by that fascinating and very significant process of getting hard tissue. So skeletons start to appear in the Cambrian, which is very helpful for fossilization, because hard tissue, skeletal-like elements, actually preserve a lot better than those soft materials. But in the very early stages of skeletonization and shells and so forth, there were often only sections of the body that had hard material. So you start to see things like early shells and sclerites, which are those hard, probably mineralized growths that tended to occur on the outside of animals' bodies. But it's, like I said, it's more than 500 million years. So you can imagine that fossilization over that time scale isn't very good. So what usually happens is the soft tissue, the skin, the organs, the gut, they rot away completely. And then when we're looking for them, we're only left with these partial skeletal elements, so sclerites, and pretty much all are preserved. So the Lobopodians were some kind of worm-like creature with feet that were kind of the proto stem form for arthropods. So you quickly call these like insect millipedes that also water-days, which are the tardigrades, those tiny night-crawling animals, and on a hoverland, today's velvet worm. And velvet worms look quite a lot like the ancient Lodontodian ancestors. They're worms with little stubby legs. But the difference is the Lodontodians had those sclerites on the outside of the body. And nowadays, on the hoverland, are just all soft tissue, or pretty much all soft tissue. So anyway, I was researching the sclerites of one particular Lodontodian, Macrodictian silicon. And it was really interesting because it's the only species of its genus to be found with both the soft and hard tissues preserved. That was a very long explanation, so I'm going to take a break and let you ask some more questions.
All right, well, that's all we've got time for, I'm afraid. No, that's interesting, isn't it? So what you were looking at with these like worm things, and the specific one you're looking at had soft and hard tissue, yeah?
That's right.
And what were you able to deduce? Because I remember one of the things I remember last year when we were talking is that when you went on that trip, and again, I cannot implore listeners enough to listen to last year's episode as well, when you talked about that journey to the paleo dig and you suddenly discovered that you had this capacity to identify fossils quite easily, particular fossils. So, so I'm interested in the skills that you have, how they've helped, and what you're able to deduce by looking at these hard and soft body parts.
Yeah, sure. So probably my best identification skills due to the fact that it is difficult for me to get out in the field, and obviously it's impossible for me to get down on my knees and dig through the rocks looking for fossils. I'm pretty good at doing the visual stuff when they're turned into photos, and they're really good at looking at those tiny details that tend to get blurred out in pixels when they get photographed. So a lot of paleo is starting to wander into that digital space. So being able to actually look at the digital representations of fossils is quite a valuable skill. I mean, they're hard to get out of the ground, and every time you dig a fossil out, you do risk damaging it. So in many ways, getting photographic evidence of it becomes a very valuable tool for future study, because in a way, it's less damaged and more accurate than the excavation process. There can be issues with that. And my data set happened to be images. So that's what I was actually working on, because I was using a statistical analysis called geometric morphometrics, which is basically analyzing in a statistical framework using more or less qualitative data. We were looking at the biological shapes of these animals. They're fairly simplistic overall looking creature. I mean, they're a long shoe, they've got little stubby legs, and they've got these 9 pairs of dark looking, sort of pocketed and perforated growths along the outside of the body. And on top of that, there's not much to get just looking at them. We don't even know where the head or the bum is. It's like, which way round was this animal? It's still very much a guessing game. So that's what they look like when they've got soft and hard tissue preservation, which we look at all of it together. So I was looking at sclerites using geometric morphometrics, because what I was doing is I was trying to ascertain how the shape of those sclerites changed across the length of the animal, and if that was indicative of some sort of trait or adaptation, but also, as they're the only definable feature or otherwise fairly featureless ruins, I was also looking at them from the perspective of ontology, so trying to determine how they grew and what size related to the shapes, and if they had instar stages or if they got bigger over time. So that was the main thing I was looking at. And in terms of results, I was able to find that there is a consistent variation between the ninth sclerite and all the others, which is indicative, although obviously not certain, that I like to think it's indicative that that was the head. So that maybe we actually found anterior. And I also was able to find, which was pretty exciting, that they had isometric growth, which means that they didn't have any of those significant lava or instar stages that we could find. It looks like they pretty much just got bigger as they aged. And that is similar to how the modern velvet worm develops. They tend to start out as small versions of a velvet worm and then grow. I apologize. I'm talking to you from home and my dogs are barking in the background.
That's fine. Let them bark. I've got people working across the road with drills and hammers, so you might end up hearing some of that as
Fair
well.
enough.
Um, and that's all fascinating, isn't it? Being able to work out the growth pattern of this animal that's more than 500 million years old. And it was really
Yeah.
hard for us to ever really get our heads around that sort of time frame. But a year is also a long time, isn't it? Because as well as having graduated from your first class honors, you're on to the next step, and that's what I want to start talking about now, and that is you have started your masters.
I have.
So, um, tell us, what's firstly, how does it feel? When everything got ticked off and they said, "Yep, you get to start your masters." What was that moment like when you realized this was happening?
Oh, it's so exciting. Actually going to start my master's. At this point, I'm talking about the date for my proper confirmation of hand itself, which is a big presentation to do. It's really exciting to be at this point in time. I mean, I took more than half a decade to do my undergrad, and then in the last 3 years, I have enrolled, completed my honors, and I'm on to my masters. It's going quickly, but also really, really well. So it's a great feeling to be looking at that next milestone getting ticked off, and then I'm going to move on to my PhD. And knowing that I've got undergraduate and honors under my belt already, and I've already started my masters, I'm confident that I will be able to go all the way to a PhD. So it's a great feeling.
Yeah, and we will have Dr. Eleanor back
I look forward to that.
on that. Okay, so what what's the master's going to be looking at specifically? And is it following on from what you've done so far, or is it flipping to something different?
Yeah, so the master's is following on after 2 years of applying numbers and little dots to macrodydian sclerites. It was pretty much concluded those are some really interesting finds that more would need to be done to make it really, really valuable. It's a good honors project, but what else can we get out of it? So I did end up sticking with the same overarching theme of research. There'll be more metrics because of the nature of the niche that will be applied to sclerites, as that's what's more readily available. That I'm looking to expand into looking at some of the other species of microdydion that aren't preserved as complete fossils. So the ones that are just the sclerites, not the soft tissue. And, we'll be looking at the ontology and the shape of those sclerites, trying to find out across the genus level. But I'm also going to be doing some work on another variety of lemniconium called quadratopora. Very hard name, very weird looking thing, that it's never been found with the rest of the body preserved, just a few sclerites. And so far only in China, but we think that there's actually a sclerite from South Australia. So I'll have a look at that. But one thing that's interesting me is just on a visual examination of the sclerites alone, there's quite a lot of similarity between microtichium and quadratopora. And that might be because lemniconiums are just a variation or a thing, and it might be because quadratopora is actually another species of microtichium. Not really sure yet. Have to do more work on that. But it's an interesting point to look at it from. And there's been some debate. Of course, it's hard to do these projects, so this has been a bit up in the air. But I'm probably going to be able to actually do some sectioning of a microtichium fossil and have a look at the minerals and the molecular structures of stem fossils that I'm interested in figuring out if these mineralized sclerites actually had biomineralization when they were alive, or if in fact they're so hard because of minerals entering the tissue during fossilization. And that might lead to some answers about whether there were components for armor-like protection, or if they weren't actually hard minerals, then they probably didn't serve a protective function. But lab work has been hard to start, so the earliest I've been doing that is the center. I can't say that's more on that one, but yeah, that would be a really interesting area.
It is, isn't it? That whole thing of working out when you're looking at at a at a fossil at a microscopic level, and you're looking at you can see that there's a process that's happened, and whether that particular process took place while it was alive or during the fossilization process.
Yeah,
To be able to just to be able to even conceive that it's possible to work that out on something that is more than 500 million years old. I always when talking about Cambrian fossils and Ediacaran stuff and some of the early stromatolites, it continues to make my brain hurt that we can look at these things and work things out.
yeah. I was always really blown away by that biomineral, biotrace side of things as well. And I'm really looking forward to actually participating and getting to do some lab work in that area because I've read journals and I've seen presentations that talk about identifying the biotraces of Cambrian and Ediacaran fossils. So I agree, it's incredible to think that in this rock, because that's what this fossil basically is now, is a rock. If you can still get traces of the organic matter enough to separate between that and the mineral structures that tell you if it's original or fossilization, it's absolutely incredible. So to be able to do that, like to be a part of that from my research, is going to be amazing.
Yeah, absolutely. So I want to ask you about so you the first class honours was done through UNE, University of
Yeah.
New England and with their
Yes, that's right.
amazing paleontology team. I'm saying that because
Yeah.
they're probably listening right now. And will the masters be done through them? And bear in mind, you're in Western Australia and they're in New South Wales.
I am, yes.
So is it going to be done with UNE again? And how will
Yeah.
that work?
Yeah. So UNA have an excellent online learning program as far as I can tell across every tier. So for undergrad, honours and postgrad, which of course is masters and PhD. So because they have the option to do any of your levels at online on an online platform, hard sessions. I can say that particular, but not online. So because of that, I am doing my masters at uni again, and I'm doing it long distance, so pretty much almost entirely from my home in Western Australia. The lab work will require me to actually be in a laboratory, but one of the leading scientists in the area of biomineral studies actually is based at Curtin University in Western Australia. So I don't have to go very far at all. So that's really amazing.
That's pretty cool, isn't it? So what? No more crazy long road trips like we talked about last time.
I did go on a crazy long road trip to actually graduate. I drove all the way to New South Wales to
Yep.
attend the ceremony. And I would personally like during my masters to head over to South Australia to the Flinders where these fossils are actually found and have a look for myself. The good part is it's not a requirement of the masters, so I can do that sort of to value add and also for fun.
I
But for the
can,
actual
can
requirement,
Yeah, I
yeah,
can confirm as a South Australian, that whole area, Flinders Ranges, which is Adnyamatna country, is some of the most remarkable country in Australia and anywhere in the world. It's old, it's ancient, it's extraordinary. It has a rich fossil heritage, a fascinating and amazing cultural heritage. There's a story about Yamoti, which we've worked out, and elders and scientists have worked out. Yamoti is diprotodon. Um,
amazing.
yeah, it's a pretty cool place to visit, and it's only 5 hours from me. So if you do go there, we might have to record an episode live in the field.
Well, that sounds like a great plan. I'll let you know if I manage to get over there. I'd be really keen to have a look at that country, not just drive through it, but actually have a proper look. And yeah, dig for some really, really old fossils.
Yeah, yeah. So you'll be able to duck up to Curtin now and again as part of it,
Yeah.
the Masters. So what about going to China?
It would be fantastic to go to China. That is the deposit where almost all these Lilliputians are actually found. The international travel is another game again, and it's interesting. The actual fieldwork, the data on country component is less challenging than getting there. I use a really big power wheelchair, big batteries, big frame, and it doesn't fold up. And basically, airlines do not take wheelchairs like mine. So I get on a plane and fly somewhere because there is absolutely no access on the transport. They don't take chairs like this, and they tend to damage them when they put them in cargo. And that's a bit daunting as an idea, as it's my whole means of getting around. So I haven't
Yes.
quite figured the challenge yet, but it would be good.
And it's interesting, isn't it? It's just trying to work through, and you've been so effective and persistent to date in being able to find ways around the issues you've been confronted with in terms of access and stuff, and a fantastic advocate for those sorts of things. But how you, yeah, you certainly wouldn't want to have it in the luggage and then you get to the other side and it's not functional in the way that it.
Yeah, absolutely. I think that would be my worst nightmare. Then I wouldn't be able to go out and do any paleontology or go anywhere. So yeah, it would be a disaster. So
Yes,
that's why I've only done road trips to date.
yeah. And there's a challenge to the airlines, like do better. Find a way,
Yeah,
find a way to. There's a segment of the population that cannot travel because of the way that your aeroplanes are designed.
yeah, I agree. Do better. We can go anywhere we want, like everybody else.
Yeah. So we've got about 3 minutes to go. It's always goes so quickly. That's because you talk a lot. But um,
I do.
so anything else you want to add? Like, oh, I'm giving you free rein to talk about anything you like, really. Just in terms of what you're looking forward to with the masters and what comes next.
Yeah, yeah. So for masters, I am looking forward particularly to this lab work component. And I actually, for a while there, did think it was going to happen. We're having a really hard time getting fossils that anyone was prepared to let us cut up. Because when you do the process, the fossil is permanently damaged, so it's not really usable down the road. Um, but my supervisor, Marissa, has just come back from a trip to China, and she says that she's got a fossil for me to do that process with, and she's also got some CT scans of the inside of the sclerites. I'm really looking forward to seeing those. I mean, you can get a fair bit looking at the outside, but I'm really interested to see what the inside of these things look like and how they were growing and developing. So other than that, that more detailed lab work and analysis is what I'm really looking forward to. And as for what next, well, master's is 4 years, and apart from the lab work and the data analysis, most of it's probably going to be writing a nice long thesis. I'm hoping to publish my other thesis in Altrinka. I'm really looking forward to doing that. And then I'm excited to get on to the next step, which will be PhD. But I haven't quite decided what that's going to look like yet. Going to focus on finishing the master's first.
Yeah, one step at a time. They're all big steps, and I
Yeah,
guess too as you work through the masters, one of the cool things about any research project is that there might be things that you're able to reveal and uncover as a result of doing the masters that then takes you and defines the way forward with the PhD. We are out of time, Eleanor.
okay.
Um,
Wow, that
so
went pretty well.
I know. So thank you so much for joining us, and we will. I'm sure in the next season we will have you back again.
My pleasure. Thank you.
It's time to spread some Paleo Jam.